Okay, we ready? All right. All right, thank you. All right. All right. Couple things I want to point, couple points I want to make before we go into the answer. All right? When you're done, use this as kind of a self-assessment for how you're doing. All right? If your answer is close to mine, then, hey, you're probably catching it pretty well. All right? If your answer is different than mine, all right, feel free to ask questions, feel free to ask me why I did one thing versus the other, and so on and so forth. Remember, this is like, I was talking about exhibition football before. Remember, this is a scrimmage game, right? There's going to be, I sound like the head coach now, there's going to be mistakes and kinks in the exhibition game, right? This is the time to work out those problems. So don't be upset if you didn't do as well as this. This is just practice, right? This is a time for you to make your mistakes so that we get them all your questions answered, and when it comes time to do it for real, you can do it well. I gave my one class earlier today a similar kind of practice exercise, and I could sense some frustration, and it was like, part of the reason I'm giving this is to get a sense of where people are at, all right? I don't expect people to be perfect at this point, all right? I expect people to have problems and questions and all that, Learning some stuff isn't easy. I mean, some of this stuff is hard stuff, and it's tricky stuff. So if you didn't do, and you didn't come up with the solution that I'm going to come up with, all right, don't feel bad. Let's talk about it, ask questions, and we'll go from there. What I'm going to do is I'm going to write my solution up there and talk a little bit about it, and we'll go from there, and we'll see how much time we have. Maybe we'll implement the tables and access, maybe not, all right, depending on the time. First of all, in looking at this, almost every piece of information that you get tells you one of three things, all right? Almost every piece of information that I've given you, and I've kind of written it down in note form here, but if it was like written out in sentences, all right? Almost every piece of information will tell you one of three things. Number one, it will talk about a new entity, all right? Number two, it will talk about a relationship between entities. Or number three, it will talk about additional attributes for an existing entity. So as I'm going to put these things up, we'll go and draw our ERD diagram. The fact that I teach many classes implies that I have a class entity, right? So I will go and I will draw on my ERD a class entity. All right. I have many students. Well, again, a student entity. Now, third thing isn't about any new entities. It's about the relationship between students and classes, right? Relationship between students and classes. A student could be in more than one class. What does that tell us about the relationship between student and class? It's a many to many. And you know what? You're absolutely right. This statement here only talks about one half of the relationship. It says that one student can be in many classes. But you all, because you've been in classes before and applying just what you know of the way schools work, all right, you know that a teacher doesn't have a class, typically, that consists of one student, all right? So even though it wasn't explicitly stated, you could read between the lines to get the other many-to-many part, right? This part says that, this statement here says a student can be in many classes. Because you know what the word class means, and you've been in classes, and you understand that classes consist of more than one student, you were able to assume that part. All right? That's important for database designers to do. I mean, database designers bring to what they know about the world to the problem that they're trying to solve. That being said, sometimes it never hurts to ask anyhow. All right? think of the IMDb example that we covered last time. All right? We talked about whether a movie belonged in more than one category or it belonged in one category. Well, we may make an assumption and say that it belongs only in one category, but as you saw, they wanted movies to be contained in multiple categories. So it never hurts to ask, is the bottom line. Even if something seems obvious to you and you're talking to the person for whom you're developing a database for, it never hurts to ask. Really, part of the skill, and it's a part we don't practice necessarily in this class, but part of the skill in database design is involved in getting these requirements, getting a list of statements about what the database needs to be able to do. And that requires good communication skills, that requires an understanding of the organization and the business and so on and so forth. So I kind of just distilled these rules off the top of my head. Really, where these rules would come from is you'd sit down and talk to a teacher and ask them those questions and try to make as few assumptions as possible. And if you have questions, it's better to ask a question and have them think, boy, they should know the answer to that, than to design a database that's incorrect. Those of you that are CISS majors, you'll take a systems development course as a capstone course if you complete the program. And in that course, you develop a system from scratch, essentially. And the skill in that course, there's technical skills, but just as important is the communication skills. So I want to say that in terms of creating the database. In your database project, when you're doing this, you need to, if you're doing a database for a club or an organization, you need to talk to people to make sure you understand the rules. All right. I said that there's multiple assignments for each class. So that actually says two things. Number one, that I have an assignment entity. And number two, that for each class there's multiple assignments. Although I didn't write it on the sheet of paper, I did say explicitly that a given assignment is only for one class. That a lab is a biology lab and not both a biology and chemistry lab. Again, the way you determine these is to say one of these has how many of these, one of these has how many of these, and therefore this is a one-to-many class. The next one's a little bit tricky because it's kind of hard to show until we do this. Remember that one-to-many can't, or I'm sorry, that many-to-many can't stand. So some of you might have right from the bat drawn your ERD to look like this. We talked about the students having a grade. Oops. Each student gets one grade per assignment. All right? Actually, we could have drawn it on this other one. I got briefly confused for a second. But we have this one up there, so we'll draw it on this. So what I'm saying is there's a grade entity, right? And each grade is related to one student, right? But a student can have many grades, all right? Each assignment can have many grades, but each grade in the grade book is only related to one assignment.